You should feel sorry for sixth hour because they have to watch a video of this. Okay. All right, kiddos, we are on 8.2. This is a specific type of sequence. It's called arithmetic. Today is what, 4/8? Yeah? For fun, I want you to find the sum of the first 100 natural numbers. Go. Don't use your calculator. You don't need it. Candy, whoever gets it first. Find the sum of the first 100. What's a natural number?
Like 1, 2, 3.
1, 2, 3, 4, 5. Yeah.
Wait, is 100 included?
Yes.
Okay.
No.
We can't use calculator.
No, you don't need a calculator.
Got it. 1,000.
Lily.
5,050.
Boom! No calculator?
No.
Yay! She deserves like lots of candy.
I don't want any candy. I'm fine, thanks.
You don't want to tell your answer?
I'm fine, thanks.
Okay. How does she do that? Is she magic?
Do you want me to tell him?
It's not that hard.
It isn't that hard.
It's not that hard.
But she was using her brain over here, right? How'd she do it?
So 1 plus 100 is 101, and 2 plus 99 is 101, and there are 50 sets of 101, so it's 50 times 101.
Do you like it?
Wait a minute.
Don't
Again, that over.
Okay, listen to it again. If you start with 1 and add it to 100, you get 101. And then if you work your way in, 2 plus 99 is 101. And 3 plus 98 is 101. And how many times are you going to have 101?
50.
50. How cool is that? Okay, so there was this, there's another way to do it? How?
1 plus 99 is 100, 2 plus 98 is 100, 2 do that 50 times, so you get.
Ooh, I like that way too. Okay, so 1 plus 99 is 100, 2 plus 98 is 100. We'll split that by 50 and then add 50 because you'll have a 50 left in the middle. Impressive. Very good. I hope they heard that. I don't know if they did. Well, maybe not. Okay, so the sum of the first 100 I shouldn't have recorded. Whatever. I can't figure it out. Okay, the sum of the first natural numbers is 5,050. Good job to Lily and Colin for both thinking about that. So here's how it happened. And this is a theorem that was created by Gauss. You will come across that name again. I have 2 centuries written on my notes, though. I have the 21st century and the 19th century. I don't know why I have both of them. I'm going to have to look it up. Okay, so basically what's happening is you're taking 1 plus, you're looking for patterns. 101, 2 plus 99 is 101, and that's going to happen 50 times. So 101 times 50 equals 5,050. You will be using this again, okay? This works with arithmetic sequences, so I'm going to define that for you. An arithmetic sequence looks like this. Make one of these funny brackets that teachers do really well, but students have a hard time with them. An arithmetic sequence is a sequence with a pattern. It starts with a sub 1. And every time what we're going to do, that's a comma, we're going to take that term and add the same difference, d. So we're going to add 5 every time, or we're going to add 7 every time, or we're going to subtract 15, or something like that. Yeah, this is a comma. Sorry. This is a comma. Okay, now, on the third term, we're going to take the first term, but how many d's are we going to add to it? 2 d's. We're going to keep repeating this pattern until we get to the nth term. So why don't up here, why don't you put a sub 1, this is a sub 2, this is a sub 3, and then we need a pattern for n. Okay, so making a pattern, every single one of these starts with what? A sub 1 plus How many D's am I going to need to add for the nth term? Say it again. N minus 1. Good. So in parentheses, I'm going to put n minus 1, and then I'm going to put D. And then close it with a bracket. Okay, so you guys are going to be expected to create explicit rules. Again, I think this chapter is a little bit difficult, explicit rules. The reason why you have difficulty is because of all the vocab. The word explicit versus the word recursive, okay? An explicit rule for this is a sub n equals a sub 1 plus n minus 1 times d. D stands for a common difference between terms. A sub 1 is the first term. You need to memorize this. There are a couple things in this chapter that I make you memorize, and there are a couple things that I give you. Okay, so here's what your homework will look like. Okay, example 1 is -6, -2. I don't know if you have any experience with this in Algebra 2 or not. I can't remember. Do you guys remember this stuff? Have you ever seen it? Okay, they will give you a sequence. It will be arithmetic because that's what section you're in. All right, that's what makes this easy. So the directions will say find an explicit rule. And the 100th term. Okay, so when you see find an explicit rule, first of all, you'll need to determine if the function is, I'm sorry, I shouldn't use the word function because not all of these are always functions. You'll need to determine that it's arithmetic. So what's this increasing by every single time? 4. So when you're looking at this, you make some notes to yourself. You got D equals 4. You note that it's arithmetic. And so since you've memorized this at the top of your test paper, you'll have written a sub n equals a sub 1 plus n minus 1 times D. And then you start filling things in. Okay? So a sub n equals, what is my first term? Trenton. -6. Plus n minus 1 stays there. The n gets to stay. And then what goes in for D? 4, the common difference. Now, you can leave it like this. Actually, sometimes the book does. Or you can simplify it. A sub n equals -6 plus 4n minus 4. A sub n equals 4n minus 10. So both answers are fine. Okay, if I want to find the 100th term, what do I need to do? Yeah, so what they're saying on the 100th term, they're saying let n equal 100. So once you have the rule, you would write a sub 100 equals 4 times 100 minus 10, which is what, 390? That's it. That's the easy one. The next one's a little bit more challenging. And you guys, we don't have very much to do today. This won't take very long. I only need about 10 more minutes probably. Okay, so example 2. When I give you this problem, I have to tell you that you're working with an arithmetic sequence. Otherwise, you wouldn't be able to do it. I'm going to give you the 8th term. And I'm also going to give you the 12th term. So what makes this problem a little bit more difficult than the last one? You don't have the first term. You don't have that key component, okay? So it's kind of like the fruit fly experiment where you're going to have to do some work to get it. Okay, I want you to write the first 5 terms. Do you guys want to try it on your own, or do you want me to just go ahead and show you? 8th term is 25. The 12th term is 41. So here are the couple things that you need to think about. If you're going to make an arithmetic sequence, you're going to need a couple of important components. You're going to need D, and you're going to need A sub 1 in order to figure this out. Does anybody already know what D is?
Yeah.
Jake, what's
I
D?
think it's 4.
You think D is 4. You're correct. How'd you get it?
Because you take the difference between 12 and 8, you get 16.
Mhm.
And there are 4 terms separating those 2 terms, so you just divide that difference by those 4 terms.
Very good. So those of you that are visual, here's 8, 9, 10, 11, 12. This is A sub 8, A sub 9, A sub 10, A sub 11, and A sub 12. You know that the 8th term is 25, and the 12th term is 41. You need to figure out how many different times you're going to have to jump. So it's all about the transition. How many jumps do you need to make? There's 4 jumps. So basically what you're doing is you're finding the major difference, 41 minus 25, which Jake said was 16, and you're dividing that by 4 different jumps to get from A sub 8 to A sub 12. So D equals 4. So what would the 9th term be? 9th term be 29, A sub 10, 33, A sub 11, 37, and then that puts you at 41. So we still need to find the first term, and here's the way that you do that. You guys, you have a lot more information than you realize. So I'm just going to use this idea right here. A sub 8, instead of counting backwards, because that's kind of elementary, A sub 8 is 25. Well, I know that if I have A sub 8 right here, A sub 1 is the first term, plus, what's my n value that I'm thinking about right here? 8. A sub n is 8, so I'm going to put 8 minus 1 in here. And what's the D value? 4. So I still have 2 unknowns right here, but can't I change A sub 8 to something else? A sub 8 is 25. So 25 equals A sub 1 plus, I'm going to write it again, 8 minus 1 times 4. So now all you're missing is A sub 1. You can solve for it. 25 equals A sub 1 plus 28. Subtract 28 from both sides. A sub 1 equals negative 3. So it wanted the first 5 terms. Negative 3, then what? 1, 5, 9, 13. Okay, so that's about as complicated as this gets, is to find the sequence or the pattern when you don't have the first term. Jake.
Can you explain how you did the A minus 1 part?
The A minus 1?
The 8 minus 1?
Oh, yeah. Keeping in mind that this is A sub n equals A sub 1 plus n minus 1 times D. So I'm using one term. I'm using A sub 8 to figure out what A sub 1 is. So if this n is 8, then this n is 8. Okay? Sophie.
So if you have that, can you technically use A sub 12 as well?
Absolutely. You could use any of them. They would all work. Good question. Okay. The last thing that we need to do today is we need to find sums. So this is the sum of an arithmetic sequence. There's two types of sequences. There's a finite sequence or there's an infinite. Which one is not possible to find the sum of in the case of arithmetic sequences? Infinite. You cannot do this. You guys, if I keep adding 1 all the time to something, you'll never be able to find the sum of it. But finite does have a formula. So we're going to write S sub n equals, and this is Lily's formula. What did Lily do? The first number and the last number, okay? So she did a sub 1 plus a sub n. Then she multiplied that by what? Half of how many terms there were. So n divided by 2. Pretty cool, huh? All right, so this was Gauss and Lily that came up with this formula. Okay, you could be a mathematician, make the big bucks. Okay, so the last thing for today, last example. Am I on 3? Example 3. Okay, I want you to find the 150th partial sum. I have to tell you that it's an arithmetic sequence, which is kind of silly because that's the section we're in, but that's okay. Of the arithmetic sequence, here's the list. 5, 16, 27, 38, 49, ... So this sequence is finite or infinite? It is infinite, but I want you to stop at where? At 150. Okay, so things that you will see on a quiz, you'll see the word arithmetic, and you'll see this word 150th partial sum. And that tells you, okay, I need to do the sum of an arithmetic sequence. So it triggers your brain to think S sub n equals n times a sub 1 plus a sub n divided by 2. Okay, you have to know which formula to choose, though I give you this one. You don't have to memorize it. So we are finding the sum of the first 150 terms. So what does n equal? 150. A sub 1 represents the first term. Write it down. What is it? 5 plus, a sub n. Do I know what the 150th term is? No. You've got to go figure out the rule and write it. Okay, so I'm going to go over to the side. You've already done this today. A sub n equals a sub 1 plus n minus 1 times d. If you want to find the 150th term, there's a gift here. What's the first term? 5 plus, what does n equal? 150 minus 1. And what's d in this case? D is 11. That's what we're jumping by every single time. So a sub 150 equals, I'll do it in my head, 123,675. I didn't do it in my head. It's on my paper. Okay. That's not right. It's 1,644. 1,644. Okay, so that goes in for right here, 1,644. All that divided by 2. So the sum of the first 150 terms is what I said earlier, 123,675. Okay, that's all for today. Let me give you guys an assignment. It'll be due on Friday. Okay, this time you are doing page 586, numbers 3 through 5, 8, 10, 25, 29, 44, 52, 61 through 63, 70, 83 through 86. Wait a minute. Really? That's it? Okay, then I want you to go back to page 577. And I want you to work on, sorry, you can't see that, page 577. And I want you to try numbers 40 through 52 even. And again, things that I don't want you to beat yourself up over. I want you to try them. I want you to try and have fun with them now that we've had some practice. I know you saw the answer key, so you know half of them are extra credit. Okay? I think the first ones you can do, and then the second part of them are extra credit. Okay? I also want you guys to do that review, that, what do I call it, MAR worksheet? MAR number 1. It's math assessment review. It's due Friday also. Okay? We'll talk about the other exponents later. Bye.